Okay. So good morning from out of Antwerp, very close to the Schelde. We are here on the third OpenCloudification webinar. I'm here joined in Antwerp by some of our partners, Tom from ID Lab and Michael on the other side from the Beacon. And then okay, and good morning, Grégoire. Welcome in any case. And then online we have some other team members which are joining from Ghent. There's Merlijn and Bruno. Merlijn, who will be presenting shortly, and then thank you also to Sean for joining in again. So today, in the next 2 hours, more or less, depending on everybody's time still available, of course, we'll be talking about some developments specifically for on the basis of cloud native technology, open cloud technologies, which are mainly served and can be used by companies which are focusing on technology development, focusing on developing new types of innovative IoT devices to a large extent as well. Therefore, also, of course, our relation to the Beacon and the reason why we do this here. We do this on the basis of a project which is called OpenCloudification / Cloco. And it's a project sponsored by the Flemish community, specifically to help companies like yourselves to get better understanding of what open cloud technologies can offer, what they entail, what it is specifically that can be used in order to serve your business and your technology development in the first place. So we've done 2 sessions, some more explorations, some more on the business side. Today, the plan was to start focusing on the use of Kubernetes and the sense of Kubernetes, specifically on the basis of a framework and facilities that we actually can also put available thanks to our partner from ID Lab. And also focusing a bit on the use of IoT types of technologies where cloud capabilities can be used. And then specifically in the domain of how can you actually also start building technologies into those devices which connect immediately into the cloud, also based upon open technologies. So that's I think what we have here in plan for today. Also, of course, with the intention to have a bit more of an interaction and a discussion potentially afterwards. It doesn't have to be recorded, obviously. But feel free to ask questions or to raise comments whenever you like. The session is being recorded. Not everything will be broadcast, of course, but the main purpose of the recording is really to be able to broadcast it as part of the series of activities that we do. And so, therefore, Merlijn, I'm handing it over right now to you to kick it off with your presentation. So, if you can share your screen, Tom, then Grégoire can also see it.
Ah, okay. So share screen.
Merlijn,
all right.
We're good to go. Yeah, we can see.
All right.
We can see the screen here from Tom, and so all good.
Great. So hello everyone. My name is Merlijn. I am a postdoctoral researcher at IMEC and Ghent University. And this presentation was made in collaboration with LSEC, specifically with Luca, who sadly fell ill. So today I am here for you to present this entire presentation. So this presentation, we want to give a bit of an overview of what are we specifically talking about with open cloud technologies, what are the advantages and what are the challenges for using open cloud technologies. And so when we talk about open cloud technologies, we're talking about open source software that can help you in the cloud and to get a cloud experience in the edge. So to find better ways to deploy applications to the edge. However, we're not here to talk to you. We're not here to convince you to not use the public cloud. We know the public cloud is incredibly useful. And so there are different layers of open cloud technologies. We're not saying move from the cloud to on-premises and use open source technologies. We're also talking about using open source technologies in the cloud itself in order to just use it where it makes sense. So if you're talking about private cloud and on your own premises, you can use OpenStack, KVM, and Canonical Mass. But then if you're using the public cloud, you can still put platforms on top of that public cloud in order to give you more benefits of open cloud technologies, even when you don't want to mess with creating your own data centers, managing hardware and things like that. So then you're using open source platform as a services on top of these public cloud providers, such as Kubernetes or OpenShift. And then finally, you can go even higher in the stack and say that I'm simply interested in open source applications on top of that. And then we're talking about things like Odoo ERP system and Nextcloud, for example, for storage. If you go and talk to companies and ask them, how is the portfolio of software that your company is using? How is this going to change in 2 years? Then almost every single company is reporting that they are going to use less proprietary software and using more open source software. And this has a lot of reasons, but this clearly makes sense. And so that's why in this presentation, I'm going to talk a bit about the benefits of open source software. Why are all these companies thinking of reducing their proprietary software and increasing the amount of open source software that they are going to use? But when you look at the benefits of open cloud technologies, it's important to ask the question, what are you migrating away of? So if you compare open cloud technologies with proprietary cloud technologies, then there are different advantages. Open cloud technologies give you different advantages than if you compare open cloud technologies with software that you build inside of your company, which we call here homegrown software. A lot of companies, when they start talking about cloud technology specifically, so operations code or infrastructure code, a lot of these companies, they think that they are not actually using homegrown software internally. However, actually, when you get into the weeds of it, when you start to actually look at different teams inside of these companies and what are these teams using in their day-to-day jobs, then you see that a lot of these teams have actually started to build automation scripts themselves to automate a lot of the operations tasks for deploying and managing software and deploying and managing cloud platforms. But which isn't immediately known to the company itself, to higher levels of the company, that there actually are people in your company building homegrown software. It's surprising if you actually go and talk to system administrators in companies. It's surprising how many system administrators are actually working on rewriting the complete functionality of Kubernetes from start, because they, for example, are deploying applications with Docker containers, and then they're writing a whole bunch of automation scripts. And then at a certain point, these automation scripts become so complex that they are basically becoming an alternative to Kubernetes. And so a big advantage of switching to open source cloud technologies compared to actually writing this software in-house is that it can really help you reduce your IT skills gap. This is, for example, it really helps you speed up onboarding. So if a new employee comes into your company and joins the operations team, for example, if your operations team is using a whole bunch of scripts to deploy and manage Docker containers instead of actually using Kubernetes, then it means that there is going to be a much longer time for this person to get up to speed and to be able to actually contribute something to that team, because they have to learn how these internal scripts work. And often these internal scripts, they're badly documented. There's always a single person that wrote the scripts and that know how the scripts work. And then you have to look into the scripts themselves in order to see what they actually do. So if you're using open cloud technologies, that is a lot easier, because everything is, if you're talking about Kubernetes, for example, everything is well documented, and there's already a high chance that people joining your organization will already have knowledge about Kubernetes, and so the onboarding will be much quicker. It can also increase your hiring pool. If you talk to people who are looking for jobs, and if you explain to them, oh yeah, we're using Kubernetes to manage our microservices, for example, these people will often be a lot more interested in such a job compared to, oh yeah, we have this internal complex spaghetti code thing that manages Docker containers. If you can just point them to open source technologies, interesting open source technologies that you're using, they will often be much more interested to actually come and work for you. And then finally, it can also improve the hiring process. So if you look at companies like Facebook and Google, but also smaller companies here in Belgium, one of the ways that they actually find people who have the skills to join the company is to just open source part of their software, or to work with open source software and look at who is actually contributing to this software. So community contributors, because these people, you know their skills because you see their code inside of your project, you see their contributions. And if you think their contributions are valuable, then you have a very good metric to assess the skills of this person. And so understanding the skills of the person before they come work with you is often a difficulty in the hiring process. But with open source technologies, you can basically, it's almost a cheat code to assess skills. Then another advantage of open cloud technologies compared to software and automation scripts that you create in-house is that you reduce your maintenance overhead because of the network effects. Because you are using open cloud technologies, because you are using something like Kubernetes, there's a whole community of people who are constantly updating the software, for example, to make it work on newer Linux distributions. Each 6 months, we have a new Ubuntu version. There are a lot of people in the Kubernetes community who are constantly updating Kubernetes so that it works on the latest version of Ubuntu. This is not the case when you're writing all these scripts in-house. And so that's one of the large reasons why it takes such a long time to update software, and especially to go to major versions of new software, because all this hidden software, all these automation scripts that are part of the operations team day-to-day job, these all have to be ported to new versions of the software. So use open source technologies in order to take care of this network effect. It's the same with vulnerability detection and vulnerability response time. It's incredibly difficult to find vulnerabilities in software that, first of all, your company doesn't even know that it has. And second of all, that a few system administrators in your operation department are the only people actually interacting with the software. However, in a large community like Kubernetes, there's constant a constant stream of audits, for example, and community members who look at the security of the code in order to find vulnerabilities and then fix them. However, it's important to put a large caveat with this. In the second half of my presentation, I'm going to talk about the challenges of open source software. And it's important that almost every single one of the advantages that I talk about here, it depends a lot on which piece of software you're actually using and the strength of the community surrounding that piece of software. So it's incredibly important that before you move to an open cloud technology, that you assess first of all, the quality of the software itself and whether or not it helps your business. But second of all, to assess the quality of the community surrounding it, to make sure that you're not jumping on a train of that project and then you are yourself responsible to maintain the entire project. And then finally, a very big advantage of open cloud technologies is that you can reuse codified operational knowledge. So the knowledge of how to deploy applications, how to configure them, how to make them secure, all this knowledge is already embedded in a whole bunch of open source projects. And specifically when we talk about Kubernetes, there is an incredibly large ecosystem surrounding Kubernetes of people putting their own operational knowledge, very, very smart people who are experts in, for example, encrypted storage or experts in security policies. They are putting their own knowledge inside of these software agents. And then you can use these software agents in order to apply best practices on your infrastructure. So, for example, if you're interested in encrypted virtualized storage, if you use Kubernetes, there is a very easy way to get it, and it's called Rook. It's an operator that you describe that you want virtualized storage, and then this operator takes care of everything in order to deploy a virtualized storage cluster that is encrypted by default. And you don't need a lot of knowledge about how all this works because this operator does it for you. And this operator itself, it has a very vibrant and active community surrounding it. So you know that the operational knowledge that's embedded in it is very good. Another example, security policies. With GDPR, for example, it's very important that you limit the amount of access that people have to certain types of data. If you want to do this and you're using Kubernetes, it's very easy to just use Open Policy Agent. And there are a whole bunch of security policies that are already predefined that you can just use and that you know that these are best practices that have been refined sometimes over years. Finally, if you want zero trust communication inside of your application, so that if one part of your application is compromised, it's much more difficult to have this infect other parts of your application, you can just use Linkerd. It already has the operational knowledge for how to do this. It already has it embedded. This is one of the big advantages of using open cloud technologies. But if you look at the benefits of open source cloud technology compared to closed source cloud technology, then there's a whole bunch of other benefits that appear. I'm very careful with my words here because sometimes people say open source versus commercial, but this isn't the case. You have commercial open source software and commercial closed source software, and you have community open source software and community closed source software. So I'm not talking about the difference between commercial versus community based. I'm talking about the difference between open source and closed source. So one of the big advantages and something that's talked about a lot is are the benefits of a reduced vendor lock-in. It's often a very abstract concept, but it basically means that you reduce the risk that your company has from changes that a vendor of software makes. So if a vendor like Google Cloud, for example, changes their strategy and changes products or sunsets products, using open cloud technologies, you reduce the risk that your company has from those kind of changes. Because there are multiple vendors, there is a wide compatibility with different environments. But to make this a little bit more concrete, I want to give an example of something that happened in the last year. So last year, Google shut down its closed source IoT offering. When you are a user, if you are a user of this offering, then you only have one choice. You have to migrate within 1 year, because after 1 year, Google will just shut it down, and there's no chance for your company to keep using it after that time. However, last year, or it's by this time almost 2 years ago, Red Hat shut down one of their open source operating systems, specifically CentOS. As a company using this open source technology, you have a whole breadth of choices available for you. For example, because there was a large open source ecosystem surrounding this operating system, there are now multiple open source alternatives and multiple alternatives with commercial offerings and wide industry backing. I put some of the logos of some of the industry partners that are backing some of these open source continuations of this project that Red Hat shut down. This clearly shows the advantage, the vendor lock-in advantage. If you're using open source technologies, then once the project sunsets, then you have options if there is a good community. If you're using closed source software, then you simply don't have options and you are forced into a decision. Another advantage of open cloud technologies is the flexible pricing. Often people say open source is cheaper, but the main benefit is actually that the pricing is flexible. It gives you a lot more flexibility than licensed closed source software. The first thing, I'm not going to name any names here, but there are some companies whose licensing schemes are completely ludicrous, where you have to basically get experts in licensing in order to figure out, first of all, how much you should pay for the software, and second of all, how you can improve those costs. Open source software, on the other hand, has an unlimited free tier, regardless of how you scale your application. So some closed source vendors, they both sell software and hardware, and they really want people to buy both from them. So they change their licensing scheme to make it more profitable to run their software on their hardware. However, with open source software, it doesn't matter which hardware you want to use. It doesn't matter how you want to scale, horizontally or vertically. The free tier stays free regardless. Same with location. If you have a cloud application and you suddenly want to bring this application into the edge on hardware in users' homes, doesn't matter, because the free tier is unlimited regardless of where you run it, also regardless of what purpose you run it for. And then there is commercial support available for this open cloud technology, if that is what your company wants. So that's what I mean with flexible. There is this unlimited free tier that gives you a lot of flexibility in where to use it. But if you want commercial support, if you want a commercial offering, you can do that on top of this unlimited free tier project. Finally, there's no end-of-life hardware. Within ID Lab, within our research group, we have a very beefy vSphere cluster. that we've been using for a very long time, and that is now a test bed, basically a Kubernetes test bed. However, the issue is that we're running vSphere on top of that hardware, and vSphere has this idea of end-of-life hardware. If hardware is older than X amount of years, it is simply not supported anymore by vSphere. So at the end of this year, we will either have to move to an open source cloud offering to keep using the same hardware, or we will have to buy new hardware. Even though this hardware is perfectly capable for doing what we want it to do, simply because the software vendor decided that the hardware isn't supported anymore, without any reason, because it's still very good hardware, we have to go somewhere else. If we were using open cloud technologies from the get-go, then we wouldn't be in this position. Increased flexibility is also, there is also increased flexibility if you want to adapt the software for your own needs. Because it is open source, you can change the code and you can integrate it much better with your existing systems. Moreover, if you want additional functionality in this software, you can actually add it without requiring the permission or without requiring an investment from the software creator or your software vendor themselves. So either you have in-house developers that can modify the software, or you choose one of the many open source consultancy services that can add these features to the open source software yourself. So you have a very wide range of options available to you if you want to change the software, even if the vendor of your software isn't interested in those features. Then another benefit is that the software is open and transparent. This has a big impact on the security of your code. Security vulnerabilities and patches are well documented and are easily scannable. With open source software, it's incredibly easy to figure out what version of software you're using and whether or not that those versions are compromised, what security vulnerabilities are present in those versions. Same with reproducible builds. Having a clear supply chain. If you get certain software, you have to know if you have a sensitive business, for example, where was this software built? Was this built on a random laptop of a random developer of your vendor somewhere in the United States? Or was it built on trusted hardware within the European Union, for example? This is stuff that open source cloud technologies are really, really good in with their software bill of materials. It's also very easy auditable by you and by independent parties without an additional cost. When you go to a closed source vendor, then you often need to pay extra in order to get the source code in order to be able to audit it. And then if you choose an open source project with a very wide, a very strong community, then you have more eyes on the code, more people looking for bugs, more people fixing bugs. And so I put it in the end, careful project evaluation is needed. Open source software, open cloud technologies are not a silver bullet that are going to make your software more secure. You have to do a very good investigation of the community surrounding it, of the quality of the software. But once you start using a project that is supported by a very good community, then you have these advantages. And so this results in IT leaders making very good use of open source software for emerging technologies. If you look at artificial intelligence, IoT, serverless computing and containers, this is the percentage of companies that are doing these innovations using open source software. However, there are also a whole bunch of challenges with open cloud technologies. As I said before, there are a whole bunch of perceived barriers and real barriers. vendors. One of the most common concerns of companies is a concern about the level of the support that they will be able to get for open source software. And in my opinion, this concern is more a perceived barrier, because if you do your due diligence, if you look at who are the vendors, what is their, what are the support levels that these vendors give us, then you have a good idea of the level of support you will be able to get. Same with compatibility, for example, compatibility with existing systems. This is a barrier that is often a little bit harder to fix. Either the open source software already has a plugin in order to integrate with your system, or you will have to either develop it yourself or contract a third party to develop integration between your infrastructure and your software and open cloud technologies. There's also concerns about inherent security of code. And here again, due diligence really helps with solving this concern. There's also the question about lack of internal skills to manage and support enterprise open source software. And this is basically where we come in with open cloudification. We are very happy to guide you through your open cloud technology transition, through this journey, to help you at every step of the way to make sure that while you are moving to open cloud technologies, or while you are adopting open cloud technologies, that you are also building the required skills in order to be able to interact with the communities and use the software in an effective manner. One of the biggest challenges of open cloud technologies is that there is an incredible abundance of choice, and not all projects are created equal. There's a whole bunch of projects in the open source cloud landscape that are built by individuals in their spare time as a hobby project that shouldn't actually be used in production, that shouldn't be relied on. So before you move to an open cloud technology, it's very important to do an investigation of what is the level of documentation that this project has. Does this project have a vibrant community, or does it have a community that is almost dying? What is the maturity of this project? How long does it exist? What is the code quality? And what is the security of the software? This is something that we also are very happy to help you with. Because of our experience in using these tools, we can give you clear examples of, okay, if you want to solve this problem, take a look at that software, but don't look at this software, because of our experience with that software. Then second of all, once you choose which open source project you want to use, there is often a second choice of which vendor are you going to use for this open source software. We also call this, in the open source community, we call this distributors. If you look at Kubernetes, for example, I think right now you have almost 200 different distributions of Kubernetes. Which one should you choose? One of the very important things to look at when choosing a vendor for your open source software is this vendor actually a contributor to the open source software? There are a lot of companies out there that claim to provide support for Kubernetes, but that haven't committed a single line of code in the Kubernetes code base. And so obviously, if you choose for a vendor like that, the quality of the support that they will be able to give you will be quite low. And then finally, a lot of vendors also have then different tiers of support contracts. So that's another choice to make. There's an abundance of choice. Another challenge is transitioning. It requires a very planned and gradual transition. Don't think that within 1 month you can switch your entire infrastructure to an open cloud technology. And don't think that if you have like a single point of, okay, now we're not using it and now we're using it, that is a very bad way to go about it, and that will definitely give you a bad experience. It really requires a lot of planning and developing in-house experience with the products and with the communities before you start to move over more and more of your workloads to these open cloud technologies. We also see that it's very important for Kubernetes, for example, that you have more than a single person in your company who knows Kubernetes. Once you start to move to Kubernetes, you need to have broad knowledge within your employee base of Kubernetes in order to make that transition successful. You need to also create institutional knowledge about failure states. Open cloud technologies, simply because it's different software, will have different failure states, and you really need to know what to do if something fails in production. And finally, you need to reserve effort for integration and compatibility work. Don't think that simply installing a piece of software will be the end-all be-all and will give you the integration in your existing infrastructure. Often there will have to be some effort to do this integration work, for example, by creating new connectors. So if we then look at a couple of best practices, as I already talked about, a best practice in implementing open cloud technologies is preparation and planning. The second best practice is collaboration with the community. One of the big advantages of open cloud technologies is this community. So it's a best practice to actually change the mindset, change how you interact with suppliers of your software in order to actually take advantage of this community. Start contributing a little bit, give your employees a little bit of time that they can use to upstream certain fixes, for example. If you keep these fixes to yourself, then you will be required to maintain them over new iterations of the software. However, if you put a little bit more effort in the changes that you make to open source software and you upstream these changes into the community, then the community will start maintaining them, and you yourself need less of an effort in order to modify it to next versions of the software. Same with training and education. And this is where open cloudification is for. We are here to share our own knowledge with open cloud technologies, share our own best practices, and give them to you. And finally, monitoring and maintenance. It's very important, for example, to keep monitoring for security fixes, but to also keep monitoring for the health of your project, for example. When we're talking about Kubernetes, Kubernetes is a quickly changing ecosystem, and so certain open cloud technologies that are that have vibrant communities right now might actually start to get less and less vibrant. The community might start to get less and less vibrant over time because a new piece of software has emerged and the community is moving over to that new piece of software. It's important to keep up to date and to actually move to the other piece of software while the entire community is moving, so that you can make use of the momentum at that point. Ulrich already explained it a little bit, but the main objectives of open cloudification is to help you in your cloud journey. And so we do this by giving you theory, giving you information that we have about open cloud technologies, but also with practice. We will also do tutorials, workshops, and hand-on sessions. I will talk a little bit about the sandbox that we have in order to get you started with Kubernetes. So this is what we're here for. We also want to tailor the knowledge levels of the content that we bring, basically on a spectrum with 3 levels. Basic level is if you are a company that has very little knowledge about the cloud or has never actually implemented it, we can help you get you started with your first steps for moving to the cloud. Then you have an intermediate level if you're already using the cloud but are looking for improvements, alternatives, and are looking for feedback. For example, is what we're doing, is this the right approach? Are there better ways to do this? We also want to tailor content to that type of user. And then finally, we have the advanced level, which are companies that have a full cloud adoption, but are still looking for the state of the art. During Open Cloudification, we will also talk a lot about our own research, about how we are moving the cloud technologies forward and edge technologies forward, and what kind of technologies to look out for, what kind of developments are interesting, what kind of developments are not interesting, and what is the state of the art in open cloud technologies. So this is the end of my presentation. I'm not sure if there's room for questions.
There is a whole room, and there is definitely room for questions. But I'm not sure if there's any. Just looking around here, everything seems to be pretty much okay. And we can dive in a little bit later on the potential practical use cases. So we're good about all of this, Marlijn. Thanks for that. Thanks for the good overview about the different capabilities about open, and also indicating some technologies and also the relation to some of the materials that you guys are investigating. Maybe just one thing to add there. There's of course the cloud native, and I think you mentioned it as well, which is bringing together quite a lot of let's say open technologies. But there's also quite a number of open technologies which are not cloud native, and which can also be, of course, utilized, and which we will also be following. So we're definitely also always interested in finding out others that you guys might be working on that we are not yet fully covering ourselves. But maybe by us covering it as well, we might be able to